Hi guys, my name's Raz, and today we'll be looking at separating the variable in the topic of integration of differential equations. So I'm going to do this video with just 5 worked examples, otherwise it is difficult to explain what to do. So example 1, we have 3y squared dy by dx equals 4x plus 1. So what we need to do is get the x's on one side and the y's on the other. And that includes the dy and the dx. So the dy and the dx will just follow the usual rules of multiplication. So we can just multiply over there. And to turn the dy by dx into a y equals, what we need to do is integrate. So we end up with the integral of 3y squared dy equals the integral of 4x plus 1 dx. And that's why it's called separating the variable, because you can see the variables have been separated on each side. So if we integrate what's on the left-hand side, we will end up with 3y cubed over 3, which is y cubed. And that will equal 4x squared over 2, which is 2x squared, plus x, plus c. So if we want to make y the subject, y will be the cube root of everything there, including the constant. In this case, if we put the constant outside of the function, the answer will be wrong. So let's go to example 2. So example 2, we have the integral of dy by dx equals the integral of cos x over e to the y. So I need to move the x and y's, so the x to the right-hand side and the y to the left-hand side. So what I end up with is the integral of e to the y dy equals the integral of cos x dx. Therefore, e to the y equals, so if we look at cos, sine differentiates to cos, so cos must integrate to sine with there not being a sign change. Sine x plus c. Well, if I want to make y the subject, y will be ln of everything there. Yep. So my washing machine's maybe going off in the background. I'm hoping that we can't hear it in the video. Find out when I edit it, eh? Anyways, so this one, example 3. Integral of dy by dx equals the integral of 2x y over x squared plus 1. So we need to move this to the left and this to the right. So we have the integral of 1 over y dy equals the integral of 2x over x squared plus 1 dx. As you've seen in another video of mine, we can integrate the right-hand side using recognition. So since this is a function and that would be the derivative of the function, the right-hand side must go to ln x squared plus 1. And we can see that left-hand side will go to ln y. Well, because our answer's in terms of ln, instead of putting c as my constant, I'm going to call it ln a. This way I can actually neaten it up a lot easier, because ln y must be equal to ln of a times x squared plus 1, since ln a plus ln b equals ln ab. And now, since we collapsed it, we don't need the lns anymore. they will cancel, so y will dissolve, and so y will be a times x squared plus 1. Next one. I encourage you to pause the videos and give them a go before I reveal the answer. So here we have the integral dy by dx equals minus 6x y squared integral of. So we need to move the y squared to the left and the dx to the right. And when we integrate y to the minus 2, we'll get y to the minus 1 over minus 1. And that will equal minus 6x squared over 2. Yeah, so what we have is minus 1 over y equals minus 3x squared plus c. So y must equal c minus 3x squared. 1 over y must equal c minus 3x squared. So y is 1 over c minus 3x squared. I think we've got one more. I've lost count of how many we've done. So is this example 5? I'm not sure. You tell me. If you're making notes, you'll know. So dy by dx equals 4x times y to the power of a half. Therefore, the integral of y to the minus a half dy equals the integral of 4x dx. So this will go minus a half plus 1 is a half. And dividing by the half is the same as timesing by 2. So 2y to the half equals 4x squared over 2, which is the same as 2x squared, plus c. Yeah? So y to the half equals 2x squared plus c all over 2, which we can just write as x squared plus c because half of a constant is a constant. But I'll avoid that now. So and obviously the opposite square rooting is squaring. And we'll get that answer. So do we have one more? Was that it? That was the end. So I hope you've enjoyed the video. I'll see you again soon.